Good morning, everyone. Today we'll talk about data structures. Data structures is a very important and interesting concept. Before we step into the data structures, let me tell you what is data structure, what is data structure, and why data structure is. Okay. Now let's see first what is data structure. Data structure is arranging the data in a proper manner. Let's see that we will be having a bulk of data in real time. If you see real time data like your Facebook data or WhatsApp data, or the even in our phones also we'll be having a lot data. So data structure helps us to arrange the data in a proper manner. As applications are very rich, we'll be having a bulk of data. So to keep all these data in a proper manner, we need data structure. Right. Now, classification of data structure. Let's see and let's understand classification of data structure. So this classification is basically two types. The one is linear data structures. The one is linear data structure. Linear data structure, and the other one is non-linear data structure. Linear data structure and non-linear data structure. Linear data structure, the name itself it tells that the data will be structured, the data will be organized in a linear fashion. The data will be organized in a linear fashion. And the examples are arrays, linked list, stacks, and queues. So probably in this video we'll be seeing what is linear data structures and what is non-linear data structures, and in the next video I'll cover how linear data structure will work and how non-linear data structure will work, and even we'll be discussing in the next coming videos how to write a simple program to perform operations on arrays. All individually we'll see. Basically, student level students will feel a more difficulty to write the programs, but I'll help you out to understand the implementation part of each and every concept. So before we'll see the fundamental concept of these topics. Okay, now let's see about each. The first is arrays. What is an array? Collection of similar data elements. Collection of similar data elements with a common name tag. Right? This is what the arrays. Now here let's see the example, because example will give you the clear concept. Now let's see, I have some data. Now my data is some A, B, C, or 1, 2, 3. This is my data. Assume that I wanted to put this data into my array. Now, as far as A is concerned, it is a character type of data. The same base also belongs to character type of data. Now let's look into this. These are integral part of data or integer part of data. So the definition of array is what? It is collection of similar data elements. Now let's see the similarity. As these three or belongs to character, we used to call this as a character type of an array. Character array of how many elements? 3 elements. Now this is what? Integer type of an array. Now integer type of an array will use for integer we'll use keyword of int. Now this is what? Array of 3 elements. So now we'll use this array to store character type of data and to store integral type of data. So this is what actually a array definition is. Now let's see what is linked list. A brief idea I told you just before that. We'll see in this video what exactly means of this, and in the next videos we'll make a complete video on arrays, including of the operations and the implementation part of an array, and the same will be seen. Now let's see about linked list. Linked list is also the same, that will be putting the data inside of the list. So arrays are continuous memory allocation. When you look at the arrays, as I have here array of 3, my array of 0 element will be at 1000. Assume this case for better understanding. Now my second element will occupy the continuous memory location. Okay, now let's see a of 0. Array of 0 is equal to 1. If it is located at 1000, now my a of 1 is equal to 2, and that will be at 1002, where integer is taking 2 bytes of memory, and a of 2 is equal to 3. Now it takes 1000 of 4. This is what continuous memory locations. Did you understand? Yes. Now look at this linked list. No continuous memory locations as of linked list is concerned. Elements will not be having continuous memory locations. Now let's see what is linked list. How elements will place in a linked list? Let's see. Linked list is a linear data structure. Linked list is a linear data structure. So your data will be stored in linear format or linear fashion. Assume that I have these data as 10, 20, 30. This is my data. Now we'll put this data in a list format. Now my data is, this is 10, now again this is 20, and again this is 30. This is my data. Now as I told you just before that data will not have any continuous memory locations, but still will be having a link to access the second element. Now this is my first element. Now first element will be having 2 fields. First element will be having 2 fields. Second also will be having 2 fields. The third is also having 3 fields. Right. Now the definition of linked list is, it's a linear data structure where element is called as a node. Element is called as a node. Node will have 2 fields. The one is data field and the other one is address field. Data field and address field. Data field will hold the data. Address field will hold the address of the next node. The address of the next node, right? Now let's see. Assume that this is my data which is occupied at 1000 location. So the 20, as it is not continuous memory locations, it will be some around 2000, and the 30, it is around some 3000. Now, as the node is having two fields, the first field is data field, this is the data field, and this is the what, address field. Okay, right. Now 2000 location is to store a 20, which is my second element. Now what is the link in between of these two? The address of this 2000 will be stored in the first node address field. Now this is my 2000. The same happens at third node case, which is here 3000. As I don't have the next node to move on, as it is my last node, I'll put here null. So this is null. When it will be null? When it is the last element, that will be the null. Okay. In detail, I'll make the other video to understand clear concept of a linear data structure, operations of linear data structure, and implementation part. Okay. Now, as of now, I wanted you to understand the basic idea of this. And the next category is stack. Stack is also a linear data structure where we'll store the data elements, we'll store the data elements, we'll insert the data elements, or we'll delete the data elements from one end, which is called as top of the stack, Now let's look into this. This is my stack. It looks like a bucket. So when I pour some water into the bucket, it will reach the ground level of the bucket, right? So now this is my 10. So I have inserted this 10 in the first. So the element which is inserted in the first, right? And now it will be in the bottom of your stack. And next I wanted to insert 20. So I told you that insertion deletion will be happens from one end. Now 20 will be a top of 10 and 30 will be top of 20. As long as you wanted to insert the data elements, all the elements on top of the previous element. Now if I would like to delete one of the element, now I cannot delete the random element. I can only delete the top of the element. So simply stack representation is LIFO. LIFO stands for last in, first out. Now if you look at this 30, which is lastly inserted into the stack, but as it is the top element, I have to delete in the first place, right? Now this is what LIFO. Now the next concept, the basic idea of this is queue. The next concept is queue. Okay, what is queue? Queue is also a linear data structure where the data elements into the queue can insert from the other end and can be deleted from the other end. We'll be having two ends for two operations. Insertions can be done at rear end. Deletions can be done at front end. Let's understand this concept by giving an example. Assume that some people are waiting in front of a ticket counter. This is ticket counter. Now once one person came to collect a ticket from the ticket counter. Now he's standing in front of ticket counter. So if the other person wanted to take the ticket, he will be forming a queue after this person, right? If third is come and he has to or she has to join after this fellows and the next people also. So if you look at all the new elements, all the new people are standing at after this, after the first, after the second, after the third. So now insertions of new element will be from one end. That end is called as rear. Once after this person is taking the ticket, the one, this first person, second person, third person, fourth person. If this one person want to, one person has taken the ticket, then he has to leave this place and he'll go simply out. Am I right? Now, so deletions will be basically done from this end, which is called as front. So front is the place where we can delete the elements. Rear is the place where we can insert the elements. So queue follows first in, first out. Queue follows first in, first out. So this video will helps you out to understand the basic concept of what is data structure and what are the classification of data structures. This video helps you out to understand this. My next video, it will be in detail content of each concept. Thank you.